Hello, 7th graders. This is Miss White, and today we're doing Lesson 11, Conducting a Stimulation to Estimate the Probability of an Event. So, in the last lesson, we used coins, number cubes to carry out stimulation. Another option for putting identical pieces of paper or colored disc into a container, mixing them thoroughly, and then choosing one. For example, if a basketball player typically makes 5 out of 8 foul shots, then a colored disc would be used to stimulate a foul shot. A green disc could represent a made shot, and the red disc could represent a miss. If you put 5 green and then 3 red discs in a container, mix them, and then choose one to represent a foul shot. If the color of the disc is green, then the shot is made. If the color of the disc is red, then that shot is missed. This procedure stimulates one foul shot. So using colored disc, describe how one at bat could be stimulated for a basketball player who has a batting average of 300ths. Note that a batting average of 300 thousandths. Note that a batting average of 300 thousandths means that the player gets a hit, on average, 3 times out of every 10 times at bat. So we need to be sure to state clearly what that color represents. Now, we know that this player gets 3 hits every 10 times they're at bat, but how can we stimulate what happens when they're at bat? To help us represent this, because we know that our baseball player makes 3 out of 10 hits, we can use 10 disc. So when using the different color of the disc, I can use 3 green disc to represent a hit, and then I can use 7 red disc to represent a miss. All right, B. Using colored discs, describe how one at bat could be stimulated for a player who has a batting average of 273 thousandths. Note that a batting average of 273 thousandths means that on average a player gets 273 out of 1,000 at bats. Now again, when we use the disc, we know that we're going to use 1,000 disc, and that the amount we make is going to be 273. So we're going to have 273 green disc, which means we have a hit. And then when we take 1,000 minus 273, we get, well, we're going to get 727 red disc, which means that we had a miss. All right, now we're going to move on to the next page, example 2. So why is using a colored disc not practical for the situation described in 1B? Another way to carry out a stimulation is to use a random number table or a random number generator. In a random number table, the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 occur equally often in the long run. Pages and pages of random numbers can be found online. Therefore, here are 3 lines of random numbers. The space after every 5 digits is only for ease of reading. So ignore the spaces when using the table. Now, let me give you an example to help you understand how we use a random number table. So let's say that a fan wants to go to a Royals game, and we know that they attend 35% of those games. Well, we can look here at the number table by looking at every 2 digits to represent out of 100. So before we do that, though, we have to understand that because we're looking at 35%, 1 through 34 is going to equal the amount that they attend. And 0, 0, and then 35 through 99 represent the amount they do not attend. Now, looking at this number table, it really doesn't matter where we start or when we finish. But for example, let's say I'm going to have the attendance in yellow and then the non-attendance in red. So here, let's say I have 22. So 22 out of 100 is going to represent that I'm in attendance. Now, what about the next number, which is 90? Well, 90 is from 35 to 99, so that means that they do not attend. Looking at our next number, we have 88. Well, we know that 88 is between 35 and 99, so again, they're still not going to attend. And then the next number we have is 86. 86 still means that they are not going to attend. Then remember that the only reason why these numbers are spaced out are just because it's easier for us to read. So when we have 47, 47 still is going to represent here that we still are not going to, or that fan is still not going to attend that Royals game. So again, we don't attend here. Now we can look at 27, and 27 is between 1 and 34, so that means that that percentage we are going to attend. And then finally, let's look at 94. 94 is going to be between 35 and 9, so we're going to mark it red as in we do not attend that Royals game. Okay, so this is really just based on probability when we use our 35% and how, we use a number table to stimulate whether we're going to a game or we're going to bat. So now let's go ahead and use it for if we, we're going to go up to bat. So we want to stimulate the bat at 273 hundredths. So we could use a 3-digit number this time instead to represent a non-hit. So what we want to do is from 0 to 273, that's going to equal a hit. And let's represent the hit in blue, okay? And then the ones where we don't hit, well, because we're talking about 273 out of 1,000, that means we're going to have 274 to 1,000 equals not a hit. And we can highlight that one green. All right, so it doesn't matter where we start out on the number table. Let's start maybe down here. So the first 3 numbers I have are 807. And I know that 807 is going to be between 274 and 1,000, so we can highlight that as green. Okay. Then the next 3 numbers we can look at is 181. Now 181 is between 0 and 273, so we can highlight that blue. All right. Now our next number is going to be 314. We know that's between 274 and 1,000, so we can go ahead and highlight that green. And then we have our next number, which is going to be 466, which is between 274 and 1,000, and we can highlight that green. And then finally, let's do one more. We have 934, and again, that's going to be between 274 and 1,000, so we can highlight that one green as well. Let's see. Okay. So this is kind of what the percentage would look like if we were going up to bat and we used a number line to help us calculate that. All right, let's start to look at example 3. A batter typically gets to bat 4 times in a ball game. Consider that 273 thousandths hitter from a previous example. Use the following steps to estimate that player's probability of getting at least 3 hits in 4 at bat. So A wants us to describe what one trial is for this problem. So we need to have 4 of these 3-digit numbers. So for instance, maybe let's look back up here again, and we can choose 4 number sets of 3 digits, so a total of 12 numbers. So I'm going to go ahead and choose these ones here. There's my 12 numbers. So now I know that the numbers I'm going to use is 78, 958, 648, and 194. Now these are the numbers that I would just use to represent for that one trial. B asks us to describe when a trial is called a success and when it is called a failure. So a success would be getting 3 or 4 hits. And a failure would be a amount of hits that would be 0, 1, or 2 hits. For C, it says stimulate 12 trials, and actually we're going to cross that off, and I only want to stimulate 3. I want to stimulate 4. So how we're going to do that is we're going to use our numbers from the previous, for number A that I wrote down. And those numbers we want to use are 78, 958, 648, and 194. Now, remember, we're still working with the 273 thousandths, and so what we want to find is a number for our hit is going to equal 1 through 273, and then a non-hit is going to equal 0 or 274 through 1000. Now looking at these numbers here, I know when I have the number 78, this is going to equal a hit. When I have the number 958, that is going to equal a non-hit. When I have the number 648, that is going to equal a non-hit. And when I have the number 194, that is going to equal a hit. So now what this shows us about the stimulation is that there is a possibility that we can hit this ball the same amount of times that we maybe not hit the ball. And if we had different numbers, maybe this data would show differently. But because we have 2 non-hits and we don't have 3 or 4 hits, well, that means that this would be considered a failure. Now for D, it says use the result of the stimulation to estimate the probability that a 273 thousandths hitter gets 3 of 4 hits for 4 times at bat, and compare your estimate with other groups. Well, what we need to do here is, because we had 4 trials, we have 1 out of 4 trials is always going to equal 25 hundredths. And so when we get that to be a percent, it's going to be 25%. All right, and that concludes our video for today. I will see you in class.